Calorimetry in chemistry is the study of heat transfer. Now, when studying heat transfer, we have to keep in mind that the law of conservation of energy states that heat cannot be created and or destroyed. It can only be transferred from one substance to another substance. So a substance that loses energy has to correspond with a substance that gained energy. So minus Q loss equals the amount of energy or heat or Q gained. So using this, we can find either the amount of mass of a substance that was added to a system or predict the temperature change of the system. To better explain this, let's do the following problem. How much copper was added to a 101 gram solution of water at 75 degrees Celsius, which increased to a final temperature of 80.1 degrees Celsius? The copper initially was at 201 degrees Celsius. The specific heat of copper is 0.385 joules per gram per degree Celsius, and the specific heat of water is 4.184 joules per gram per degree Celsius. So for copper, the MC delta T, let's figure out the values from the question. Mass, we're solving for the mass of the copper. The specific heat is 0.385 joules per gram per degree Celsius. The temperature change, the final temp was 80.1 degrees. The initial temperature was 201 degrees, so we're left with a temperature change of minus 121 degrees Celsius. For the water, the mass was 101 grams. The specific heat was 4.184 joules per gram per degree Celsius. And the temperature change was an increase of 5 degrees Celsius. Now, when we plug this into our equation, the mass, we then solve for the mass of the copper, which gives us a value of 45.4 grams. In the proper significant figures, this number is reduced to just 50 grams. Now, on your own, please try this equation. We'll walk through it when we come back. What will the final temperature be of a 150 gram solution of water at 25 degrees Celsius when mixed with a 25 gram solution of 80 degrees Celsius water? Okay, let's plug in each side of the equation. The hot water is going to lose energy, so there's 25 grams. The specific heat is 4.184 joules per gram per degree Celsius. And we're going to solve for the final temperature, or X, here. For cold water, the mass was 150 grams. The specific heat, again, is 4.184 joules per gram per degree Celsius. And again, we're solving for the final temperature, when the initial temperature was 25 degrees Celsius. Okay, so plugging all of our values in, this is what we get. Since 4.184 is actually on both sides of the equation, that can be canceled out. We then simplify this to using algebra. We are left with 33 degrees Celsius.